Okay guys, so this video is to help you with the skills that you are going to be responsible for today. So we're going to start by talking about a combining like terms problem. So hopefully you already did this one, but let's go ahead and look at number 14. So I have, if you guys notice, I have an XY and a YX, which are the same. I have an X and I have a Y. So I'm going to go through and I'm going to start by underlining my XYs to kind of set those apart. Then I'm going to underline my X's. And you guys notice that I'm also underlining the symbol that goes in front of it, just so that I pay attention to whether it's positive, negative, or what. And then I'm going to underline my Y's. So we talked yesterday about the way that we're supposed to write it is in alphabetical order. So if I have X, Y, and XY, I know that X comes first in the alphabet. So I have X and then another X, and they're both positive. So that's going to give me 2X. Then next I have XY and YX. So I'm going to write it as XY because we know commutative property says XY and YX is the same. So I have a positive 1 plus another positive 1. So that's 2 plus another positive 1 plus another positive 1. So I have 4. So plus 4XY. And then last I've got Y, and I have minus Y and another minus Y. So it's kind of like negative 1 plus negative 1. So that is minus 2Y. The other way that I could have written it is 2X plus 4XY plus negative 2Y. I know some of you guys like to write it like that. So again, my strategy is to underline my different terms, then combine them together and write them in alphabetical order if I can. If that step of writing it in alphabetical order is tough for you, I'm okay as long as you get your terms combined. So, all right, so now we're going to do a little bit of problem solving with a couple of different types of equations. So I'm going to start with the simplest one. And this is the model that we've been looking at since we started with our two-step equations. So when I look at this, I know I have to identify what's happening to my variable. So it's being subtracted by 4 and then multiplied by 2. But this subtract 4 is where I'm going to start. So I'm going to undo it using the opposite operation. Whatever I do to one side, I have to do to the other. So these guys cancel, leaving me with 2x equals 14 plus 4 is 18. And then I have 2 multiplying by my x. So now I want to undo that with the opposite, which is dividing by 2. So times 2 divided by 2, it cancels out. 18 divided by 2 is 9. And you all know before I walk away, I substitute my answer back in to double check my work. So 2 times 9 is 18, minus 4 is 14. Okay, so here's another type of problem where instead of doing multiplication with the variable and the number, we're doing division. So when I look at this, I see that it's being divided by 4 and my variable is being divided by 4 and 2 is being added to it. This is my easiest one to start with. So I'm going to do the opposite operation. So the opposite of adding 2 is subtracting 2. Whatever I do to one side, I do to the other, leaving me with 6 equals b over 4. And by the way, when you see this, I know there are a couple of you where it makes you nervous to have, it feels like your stuff is switched. If you want to rewrite it to this to solve it, that is fine. That is the same thing. It's not changing anything in our equation. So anyway, back here, now I have b divided by 4 equals 6. So the opposite of divided by 4 is times 4. Whatever I do to one side, I have to do to the other. So b equals 24. Now I'm going to go ahead and rewrite it, substituting that answer back in. So I have 24 divided by 4 is 6, plus 2 equals 8. So these two types have seemed like they've been pretty simple for you guys. I feel like this is where it gets a little bit more challenging for you, but it shouldn't. So what we should notice is we have m plus 3 over top of 8. Now, I know we want to get to this variable, but we can't do anything until he's on the ground. And this divided by 8 is keeping him from being on the ground. So we have to do opposite of divided by 8, which is times 8. Whatever I do to one side, I have to do to the other. So these guys cancel, leaving me with m plus 3 equals 40. Now we're in familiar territory. So I'm adding 3 to my variable. So I have to do the opposite operation, which is subtract. M equals 37. Now I'm going to substitute that answer back in. 37 plus 3 divided by 8 equals 5. 37 plus 3 is 40. 40 divided by 8 equals 5. Okay, so here we've got distributive property involved. So when we see this, this is our don't step, right? Our don't call me after midnight. This is our don't. So when I see this, I know that this 6 has to multiply by everybody inside. So 6 times 5 is 30. 6 times m is 6m. And then it's addition in the middle. And now I solve. So I know that I'm adding 30 and multiplying by 6, but the adding 30 is the easiest thing for me to confront. So this is a plus 30. I'm going to undo that with a minus 30. Whatever I do to one side, I do to the other, leaving me with 6m equals 24 minus 30 is negative 6. I know that I want to get m by itself. I want to isolate that variable, so I have to divide it by 6, not m, crazy. And that leaves me with negative 1. Then I'm going to go back and substitute that negative 1 in to see what happens. 5 plus negative 1 is 4 times 6, 24. So none of this is new. This is the stuff we've been working on the last couple of days. So this should be something that's pretty routine for us. Now this down here is combining the combining like terms that we were working on yesterday, but it doesn't really change what we're doing. We just have to combine like terms first. So that's our call step. Okay, so when I look at this, I don't have any distributing to do, but I do have like terms on the same side of the equal sign. So I've got a plus 4x and a minus 2x. So I can combine these guys together, which leaves me with plus 4x. And I have negative 5 plus 4x, because at negative 5, I don't have anybody that can combine with him. And then I bring down my 7, and now I solve. So now I have a two-step equation. So I want to get to this, but I got to go through this first. So the opposite of subtracting 5 is adding 5. Whatever I do to one side, I do to the other. So that wipes out. I still have 4x over here. 7 plus 5 is 12. Then I look to see, what do I do next? And I had 4 times x. So now I have to undo that with 4 divided by x. And that leaves me with 3. So now when I substitute, it looks a little different because I have to actually substitute twice because my variable shows up 2 times. So this is 12. 4 times 3 is 12. And 6. So negative 5 plus 12 is, what do you guys think it is? 7. It's 7. Minus 6. That doesn't work, does it? Did I do something wrong here, guys? Looks like I did something wrong. Let's see. Plus 5 plus 5 plus 4x. Oh, duh. So I said that I was going to do 2x because positive 4x and negative 2x. I said I was going to do 2x, but I didn't actually do it. That was kind of silly. So hopefully you guys see why I changed all those 2's, because when I combined those like terms, I should have had 2, and instead I had 4. So I just went and switched those. I switched those 2, and then that meant I was dividing by 2. So now my answer, because instead of dividing my 12 by 4, I was actually dividing it by 2, my answer is 6. So now let's try it. Hopefully this will be a little better. See, guys, everyone makes mistakes. So 4 times 6 is 24. 2 times 6 is 12. So now I have negative 5 plus 24, which is 19, minus 12, which is 7. That right there was a